In this short video, I'd like to discuss the basic file storage APIs in Codename 1. I'll try to keep it relatively simple and skip over some of the more complex ideas such as parsing, externalization, etc. I'll start by talking about storage and file system. Storage is a high-level abstraction. It might be implemented on top of file system, but if you rely on that, you might fail on the device, as this isn't always true. Storage is more portable. It doesn't support file hierarchy such as directories. By contrast, in file system, we must use full file paths always. Storage is tied directly to the app and is usually private. This isn't guaranteed for file system. Storage access is also cached for performance where file system access isn't. But this brings us to a bigger core concept of mobile development. Apps on mobile devices are completely isolated from one another and can't access each other's storage and usually can't access each other's file system files. This isn't always the case. Android allows some restricted shared file system access, but this is pretty tricky to pull off in a portable way. Before we go to the code, notice that in order to use this code, you will need to import the CN class static. Once you do that, you can open a storage input or output stream and work with either one using standard Java I/O calls without a problem. Working with a file system is pretty similar to working with storage, at least on the surface. But notice that the path to the file must include an absolute path and can't be relative. SQLite is the de facto standard for database storage on mobile devices. In fact, it's the world's most popular database and is installed on billions of devices. Because SQLite is so easily embeddable and customizable, it has fragmentation issues, which I will discuss soon. It's available in all modern ports of Codename 1. However, the JavaScript port is problematic in this regard, since HTML5 doesn't have a finalized SQL standard. Some of the browsers have a deprecated version of the standard, which is what we use there. SQLite is great if you have a lot of data that you need to query, sort, or filter often. Otherwise, you will probably be better off using storage, which is far simpler and more portable. The SQLite database file uses a standard format and is physically stored within the device file system, which means you can reach the physical file like any other file. I mentioned fragmentation, and the biggest one is probably thread safety. SQLite isn't thread safe on iOS, but it is on Android. That means that if you don't close a cursor and the GC closes it for you, this might trigger a thread issue and a crash. There are also portability issues in the SQL language itself. For instance, in transaction isolation. The JavaScript port isn't portable to all browsers and doesn't support some features such as including an SQL database within your app bundle. The query API is pretty simple. We can iterate over rows in a query and pull out the column values. Notice that cleanup is crucial, as the GC might be invoked if we don't clean up after ourselves. So handling the edge cases of the exceptions is essential. A very common case is including an initial SQL database that ships with your app. This allows you to include some initial data within the jar or download initial data from a server. You can install the database into place by using the getDatabasePath method and using the standard FileSystem API to copy the data into place where the database should be. Here are a few tips and best practices when working with storage. The first is pretty crucial. You need to understand mobile app isolation, as I discussed initially. Mobile apps don't have desktop concepts like file open or file save dialogues, since there is no concept of a shared file system. That's something you need to get used to as a mobile developer. The standard storage should be the default mode you use. The other options are harder and less portable, so pick them up only if you actually need them. When porting code, we have some helper classes in the IO package that you should notice. This is true for file, URL, and other classes. Check the Java doc, as many classes might not be in the same place, but the functionality should still be there. Always use app home when working with FileSystem, unless there is a real special case, in which case consider the fact that you will be writing code that isn't as portable. Preferences is great for simple data. I see developers completely forget it's there, and others try to overuse it for everything. It's great for things like application settings, which is the exact use case you should apply it to. Thanks for watching. I hope you found this helpful.